June 2016, paper 6, variant 3. Question 1, he's asking for the labels. It's a syringe or gas syringe. This experiment is very important. He's trying to calculate the percentage of oxygen in the air. فهو بدأ ب 50 centimeter cubed of air, and he started heating and moving the air backward and forward over the copper so that oxygen may react مع copper and form copper oxide. And then he will measure the final volume of the air, which he discovered it's 40. That means no oxygen was 10 centimeter cubed, 50 minus 40. He's asking for an arrow where heat is applied. This is the place you heat the solid, not the gas. You always heat the solid, and then you pass the gas over it. The color of the copper changed from brown or reddish brown or orange to black, which is the color of copper oxide. You started with copper, you turned into copper oxide. From the results, work out the percentage of oxygen in air. As we agreed before, oxygen is 10%. So if the 50 centimeter cubed is equal to 100%, يعني دي الكمية اللي بدأنا بيها, this is the 100%. So the 10 centimeter cubed, which is the amount of oxygen, equals how many? 10 times 100 over 50, it's 20%. Question 2, it's a reaction between dilute hydrochloric acid and copper sulfate solution. Okay, and in this reaction, he used a measuring cylinder to put 10 centimeter of HCl in a boiling tube, and then he started measuring the temperatures and adding the metal and then measuring the final temperature. In each experiment, he changes the metal he used. These are the reading: 22, 21, 24, 25, 23, 61. The temperature rises 3 to 37. Then in B, he's asking for this gas, which gas gives a pop sound with a lighted splint. Of course, it's hydrogen. Experiment 4, he added copper sulfate solution, okay, and then he started measuring the initial temperature. Then he added magnesium and measured the final temperature and calculate the temperature rise. The solution, he's saying that experiment 5, he repeated experiment 4 using 1 gram of iron instead of magnesium. Okay, so the solution turned colorless and a brown deposit formed. So he added iron to copper sulfate. This is a displacement reaction. Iron sulfate will be formed and copper will be displaced. Okay, use the thermometer diagrams to record the results. 21 and 24, 46 and 29, the differences are 25 and 5. Finally, he asked for a bar chart. The bar chart you should choose a scale that makes the highest bar chart pass through half of the y-axis. So this passed half the y-axis, so the scale is acceptable. 10, 20, 30, 40, 50, 60, 70. If you chose a correct scale, you take a mark. In the bar chart, the differences between every bar should be equal, and the label of every bar should be placed in the center of the bar, like I did here. This is the bar chart. The labeling, the y-axis scale is for a mark. The labeling of the bar charts is for a mark, and drawing the actual bar charts accurately is for the third mark. Use the experiments to answer the following question. Which experiment produced the largest temperature rise? Obviously, it's experiment 3. Why? Because you used magnesium in this experiment, and in the rest of the experiments, you didn't use a more reactive metal. So magnesium is the most reactive metal used in the experiments. That's why it produced the largest temperature rise. Finally, explain in F, explain the observations in experiment 5. These observations that say that a brown deposit was formed. Okay, what happened actually is that iron displaced copper because it's more reactive, and copper was formed by its own, which is the brown deposit. So you must say that iron is more reactive, or that iron displaced copper, and that copper was formed. That's the reason for the brown deposit. So just why potassium was not used. We never use group 1 metals in these reactions with acids because they are dangerous or very reactive or violent, or violent metals, or will form a very violent reaction. What is one advantage of the measuring cylinder? Quick or easy to use. Of course, its disadvantage is that it's inaccurate, but he didn't ask here. Then he's asking for one improvement to increase the accuracy of the experiment. Okay, you could use a burette or a pipette instead of a measuring cylinder, or you could insulate the apparatus to reduce heat loss to the surrounding. Any temperature measuring experiments, أي experiment بتقيس فيها temperature, one of the best things to do is to insulate to decrease the heat loss to the surrounding, or of course use a burette or a pipette instead of the measuring cylinder. Okay. You can't you don't say here repeat and take average. Repeat and take average is said when he asks for something to increase the reliability of the results, not the accuracy. Reliability. Question 3, a mixture of two solids G and H was analyzed. G was zinc nitrate, which is soluble, and H was just insoluble in water. He started making tests for the filtrate. Drops of aqueous sodium hydroxide were added. Aluminium وzinc وcalcium الزنكة بيدوا white PPT. Zinc is always soluble, so white precipitate soluble in excess. Zinc dissolves in everything. The second portion, the test was repeated using aqueous ammonia, the same results, white precipitate, soluble in excess. This, you take 1 mark for white, 1 mark for precipitate, and 1 mark for soluble. Here you take 1 mark for white precipitate and 1 mark for soluble or dissolves. Then he did the test of silver nitrate, which is the test for halides, and we don't have a halide, we have nitrate in G, not halide, so no change. And then he added aqueous sodium hydroxide, aluminium foil, and heat, which is the test for nitrate. The result is bubbles or fizzing, and the gas turns damp red litmus paper blue, which is, by the way, ammonia gas. A mark for bubbles or fizzing, a mark for red litmus paper turns blue. Then he is testing the residue, which is the insoluble one. He added an acid. Effervescence of a colorless gas which turned lime water milky is formed. So this is carbon dioxide, and of course the anion was carbonate. And then he did a flame test. The flame that gives, the metal that gives a red color with the flame is lithium. Final experiment, he has nickel sulfate 6 water, which means hydrated nickel sulfate crystals, and he wants to plan an experiment to obtain a sample of pure water from this salt. So I have a crystal, and you want to get the water of crystallization from it. Your answer should include a diagram, any expected observation, and the test to show the presence of pure water. Okay, the experiment will be simple distillation. You need to get rid of the water and then get it again alone by its own. So you will heat the crystals, evaporation of the water will take place, it will pass through the delivery tube, through the condenser, and it will condense in a beaker on its own. Of course, the color of the crystals will change when they are heated because they lost water. So 1 mark for heating the crystals, 1 mark for a condenser, and 1 mark for a beaker where water droplets are falling in. A mark for stating that the color of the crystals will change. You can say it becomes paler or it just changes, you will take the mark. The test for pure water, you can never say anhydrous copper sulfate or anhydrous cobalt chloride because these are chemical tests and they do not prove that the water is pure. He here insisted that you test that the water is pure. The only test is measuring the boiling point. It should be 100 degrees Celsius sharp. This was June 2016, paper 6, variant 3 by Mr. Marco Medhat.